Hi everyone, welcome to my channel. In today's video, as promised, I have come up with an efficient solution to TwoSum problem. You can look into my previous video to understand the question better. So to give you a gist, we're given an integer array and a target value. So we are supposed to find out two digits in this integer array, which when added together will produce the target value. Okay, so in this example, like you can see, a 2 plus 7 itself gives 9. So our output will be the indices of these two values, which is 0 and 1. So let's quickly jump into the solution. Um, you can see that I have kept the previous solution here where we used a nested for loop to find out the target value. We kept adding the first value with the second, and then with all the combinations, and found out if the sum of them gives the target value or not. And here the complexity was big O of n square because we're using a nested for loop. So to get rid of such a bad complex algorithm, I've come up with a simpler one with the help of hash map. So what my algorithm is doing is pretty simple. So let me just start explaining what I am doing, and then we can write the code. So I'm making use of a hash map which contains two integers, the key and the value. Okay, so we have a map which has integer and integer. Okay, and what am I doing here is I'm going to run the loop just once through all the nums values. And what I'm going to see is, so let's take an example, this itself. Okay, so our nums integer array is 2, 7, 11, 15, and we're looking for target, let's say 18 instead of 9. So our answer should be 1 and 2 because 7 and 11 gives you 18. So what are we going to do here is we keep checking if the map, this particular map, contains target minus every element of the nums array. So we're going to run a loop, right? So it starts with 0 until 0, 1, 2, 3, and we're going to check if 18 minus 2 is already available in the map. Okay, so let's see. For the first step uh, is 16. Does the map contain a key called 16? No, because this map is currently empty. So if it's not available, if it's not there, then what we do is we simply add it to the map. What do we add? We add the difference, and we also add the I value in the loop, so which is basically 0, right? And so let's go to the second loop. That would be 18 minus 7, which is 11. Does the map contain 11? No, it does not. So what do? We just add 11 and in this index value, which is 1. In the third loop, now we say 18 minus 11, which is 7. Does the map contain 7? Yes, it does. So we break here, and what do we return is the value of this particular key. So we're saying that whenever we find the target minus nums of I value, which is 7, in the map, wait a second. In the map, we don't actually store the subtraction result, but the key itself, which is nums of I. I mean, we store nums of I as key. So here also we will store 2, not 8, 16. Okay, so if the map does not contain the subtraction result, we store the actual nums of I value and the I value here. So in the second loop also, since 11 was not found, we put 7 here and the I value 1. And in the third loop, we are asking if the map contains 7. It contains 7 as the key, right? So when it contains the key, what are we supposed to do? We just return the value of that particular key, which is 1, and the current I value, which is 2. So now we have actually, you can see that we have got the result, right? 7 and 11, the indices of 7 and 11 are 0, 1, 2, 3. So it's 1 and 2, right? So we got our answer. And as soon as we get the answer, we break. So let's try this with another example. Let's say 0, 2, 3, 4, or let's say just odd numbers, and our target is 3. Okay, so what do we do? First step, in the first loop, we check if 3 minus 0 is available in the map. In map, no. So what do? We say map dot put off, not add, sorry. So we add, what do we add? We add the nums of I value itself, which is 0, and the I value, which is 0 here. And in the second loop, we check if 2, no, 3 minus 2, which is 1, is it in map? It's not. So what do? We just add the value 2 and the I index, which is 1. And in third loop, we check if 3 minus 3, which is 0, does it contain, is 0 a key, the 0 key already available in the map? Yes, we have it over here, right? So when we have an answer yes, what do? We get the value of the 0th key, which is 0, and the current I value, which is 2. So as you can see, this is the right answer. So when we're adding the nums of 0 and nums of 2, which is 3, 0, so 0 plus 3 will give the answer 3. So our algorithm works. So let's just code this. So what do? We say, you can pause the video and code yourself, or you can code together with me. Okay, so let's code this. First things first, we create a map which holds 2 integer values. Let's call it sum map, and it's a hash map. Okay, I initialized it. And what are we going to do? We are going to run a loop from 0 till length minus 1. And what are we doing here? We are checking if sum map dot contains key of, what is, we're checking for the difference amount, right? So that would be target minus nums of I. If it contains the key, we return, right? If it's yes, we just return. Since the return type is an integer array, we will initialize the integer array, and the values that we're sending would be the value of the key, which is sum map dot get of target minus nums of I. This is one value, and the next value is the ith value, right? So that's it. And if it does not contain, so if the map does not contain this particular key, whenever it's no, we just simply add these values to the map. What do we add? We add the key, sorry, the key is nums of I, right? And the next value is I itself. That is it. And we know that we're always going to have one solution. So by the end of this, we would have already returned but since we are supposed to give a return value outside as well, a generic one, let's simply return null. And let's see if this code works. It's taking some time. Okay, it works for this input. Let's see if it works for all the test cases. I checked it some time back, and our previous solution ran for 51 milliseconds, whereas this ran for just 1 millisecond. So it's pretty efficient, you can say. It's also faster than 99.57% of submissions here on LeetCode. So yeah, I think it's pretty good. So that's it. If you have better solutions, maybe which are faster than 100%, or if it runs at 0 milliseconds, just let me know and we can learn together. So yep, that's it. I'll see you in the next video. Take care. Bye.